I'm Larry Ross, Director of Space Programs at NASA's Lewis Research Center in Cleveland, Ohio, and I'm your host for this 11th program in our 13-part series, Journey Through the Solar System. Now let's go back to 1979, when a Pioneer spacecraft launched from Earth by the Lewis-managed Atlas Centaur rocket made its closest approach to Saturn, the sixth planet.
We received several pictures yesterday afternoon and evening, and we'd like to run through some of those now. This is the one that came in here at about 3 o'clock yesterday afternoon. This is by far the most spectacular picture we have so far. This is raw data. It has not been processed in any way. We can see the big banded planet, and of course the ring system is very prominent in this picture. Also prominent is Saturn's largest moon, Titan, in the upper right-hand corner. Titan is a very large moon, 3,600 miles in diameter, almost planet-sized. So the Pioneer Saturn mission continues to go very, very well. We're about 50 hours now from closest approach on Saturday morning. This is Pioneer Saturn mission operations.
On Voyager, we heard a lot of, or some speculation about organic molecules and the possibility that within the clouds there was a belt or zone or something where the temperature is comfortable for life, unlike this room.
Right up here.
Are similar speculations possible or reasonable for Saturn?
There almost certainly is a zone as you go down where the temperatures are comfortable for life. And even the mixture of elements is probably adequate for life. There's carbon, hydrogen, oxygen, nitrogen, etc. Of course, there's no solid surface for the life to cling to, and there are convection currents carrying these molecules, if there are any molecules down there, and there certainly are. If there are any organic molecules, we don't know, but let's assume there's a accidental organic molecule. It will soon be carried to some zone, probably deeper, where it's much hotter and where the molecule is dissociated. So I don't hold much chance for floating organisms in either of these planets' atmospheres. From the bulk density of the planet, the fact that it's only 7/10 the density of water, we know that it's largely made of hydrogen. But there's a little bit of heavy stuff, and it's close enough to be the extra stuff you need is rather close to what you'd get if you just took solar material. Yes?
What kind of information will you be looking for to indicate some kind of life form on the moon, Titan?
On Titan? Really none, but let me now modify that simple answer. The question of life on Titan hinges on a number of factors, but mainly the temperature of the surface of Titan. If it's warm, such as above the freezing point of water, then we could say that there's a possibility of life on Titan. Now, unfortunately, now we are a temperature measuring device, so we are relevant to how warm the surface is. Unfortunately, we can't see through the clouds. So if there are a lot of clouds in the atmosphere, we're just going to see the cold cloud tops. I have some hope that we will be able to say whether Titan has a thick atmosphere or a thin atmosphere. If it has a thick one, then there's hopes that below the clouds there's a gradually rising temperature and ultimately a warm temperature at the ground.
Now, Titan is particularly interesting because it's one of the planets that has a reasonable atmosphere associated with it, and it contains at least methane, which we believe may have been one of the ingredients on some of the early, in the early primitive Earth. And there are also indications, other indications in the atmosphere of Titan that there is organic chemistry going on.
Actually, there have been some radio observations rather recently that show that the temperature at the surface is cold, not all that different from the temperature at the cloud tops. And this is sort of a suggestion that really the atmosphere isn't all that thick, and the cloud tops are not all that far above the surface, and therefore the atmosphere is thin, sort of a Mars-like atmosphere.
So does that throw both a greenhouse and a inversion atmosphere model out the window?
Well,
It's thin.
these observations, these radio observations, will throw out the greenhouse model. They tend to throw it out, and they tend to throw out the possibility of life if there ever was one, because Titan is therefore much too cold.
I understand one of the things that you've been looking for is the magnetosphere.
Well, first of all, I'm talking about the magnetic field of Saturn. The Earth has a magnetic field, and because the Earth has a magnetic field, and when you take your compass, it points north and you know where to go. Jupiter has a magnetic field also, and we expected Saturn to have a magnetic field. And you need a magnetic field, a global magnetic field, in order to have radiation belts. Of course, the Earth has radiation belts. Jupiter has very strong radiation belts. We felt that the interior of Saturn is such that Saturn would more than likely have a magnetic field. And yet the solar storm that we're encountering as we are approaching Saturn is such that that magnetic field was masked. And so we kept getting closer and closer and closer to Saturn and no magnetic field. And early this morning, we crossed the standing bow shock wave, which results as a consequence of that magnetic field and the impact of the solar wind, which immediately told us, yes, indeed, Saturn does have a magnetic field, and we were even able to compute what the strength of that field was.
On details on the ball of Saturn, on the planet Saturn itself, there is not much in the way of spots, which is a bit disappointing because we had hoped to get precise rotation rates and thereby a better information on jets and streams in the atmosphere of Saturn. The structure, however, of belts and zones is beginning to be seen and looks somewhat different from that of Jupiter, whereas from the Earth already we knew that there are in an hemisphere, say the northern hemisphere, which is the one that we're observing best right now, on the order of 5 belts and 5 zones. So that was known from ground-based observations. It now looks that there are many more of these bright zones and dark belts, perhaps twice as many.
This is Pioneer Saturn mission operations. The spacecraft has now moved to within 700,000 miles of the planet Saturn, and it's moving closer at just about 26,000 miles per hour. As we learned in the press briefing, we now believe we know what our problem with the data has been. There was a major solar event some weeks ago. Particles from the sun have made their way out into interplanetary space and have now enveloped our spacecraft and the planet Saturn. The most apparent result of this will be smaller pictures on our screens, and we will not be able to show as much area of the planet in each image as had been expected.
Since I'm a radio man, I'm kind of fascinated with the radio system of the Pioneer and of the DSN, and I'm very impressed by the fact that all of these data are received from a distance of just about exactly 1 billion miles. At this distance, if you are transmitting 1,024 bits per second, at any given time there are 5.5 million of those bits strung between here and Saturn, traveling at the speed of light, 5.5 million. And they're spaced 182 miles apart. And with that, I'll quit.
At 7:36 a.m. this morning, the spacecraft will pass through the ring plane at Saturn, and this is probably the most dangerous part of its journey. Even though the spacecraft is going by Saturn outside of the three visible rings, they're the three rings that we can see from Earth, scientists are quite sure that there is a great deal of material which lies outside of the outermost visible ring, the so-called A ring. Well, Pioneer Saturn is going to be going through that, and it will take less than a second for it to penetrate the ring and move through it. But if it should encounter a piece of debris, it could be the end of the mission right there. This first view is a close-up view of the equatorial region of Saturn. I think it's very interesting and has caused quite a bit of comment here in the Mission Operations Center. First of all, the block in the upper right has no meaning. That's an artifact introduced into the image as we display it here by the computers that process the spacecraft data as it comes from the spacecraft. So the part we're interested in is the portion below the middle of the screen, the lower half of the screen. And what we're seeing there is a portion of the cloud tops at Saturn near the equator, and the stripes that we see to the left that move diagonally from the left up toward the upper center are a backlighted view of Saturn's rings. But the most interesting thing, perhaps, is the shadow these rings cast on the surface, or the cloud tops at Saturn. Time is 9:03 and 40 seconds. Right now, 20 more seconds, and we will be able to confirm the spacecraft has survived. 15 seconds. 10 seconds. 5, 4, 3, 2, 1. We have a mission. The Pioneer Saturn spacecraft has survived the crossing of the ring plane.
Our micrometeoroid detector on the spacecraft received 2 hits. Now that is the maximum number of hits it can achieve in an 80-minute period. So it could have been quite a few more hits than 2. So there's no question we did go through a region that has some debris in it.
And receivers reported out of lock. Receivers are out of lock. The spacecraft is behind the planet. We no longer have communications with the spacecraft.
The cost of a planetary mission I like to measure in units of a beer. We all know what a beer costs. We all know what a beer means to us. The trip we're going to Saturn now is a real cheapie. We got 2 flybys of Jupiter by Pioneer and now one of Saturn for 2 cans of beer per person. Now that's cheaper than by a long shot than the cost of going to a movie today. And I can't help thinking that's worth it. Do you agree?
This is Pioneer Saturn mission operations. A minute and a half now from the receipt of telemetry for the second ring crossing. 4 seconds. We're through the time. The telemetry continues to look good. 4 minutes now after the nominal time. Pioneer Saturn seems to be safely through the ring plane and still in business. This is Pioneer Saturn mission operations. The spacecraft is now 760,000 miles away from Saturn and moving away at about 25,400 miles per hour. Yesterday, during a press briefing yesterday afternoon, some of the findings from yesterday's encounter at Saturn were announced. These include the possibility of the discovery of a new moon at Saturn, also the discovery of a new ring, and the so-called Pioneer division, or perhaps the Pioneer gap, between this new ring and the outside of the A ring, which is the outermost ring which is visible through Earth telescopes. We also announced major structural features have been discovered in the Saturn's atmosphere, and also made the first ever temperature measurements of Saturn's rings.
There are a few anomalies, but we've learned to live with it. And so these pictures that I will be showing you will not at all be perfect. There will be some missed scan lines in there and so forth, but we have the bookkeeping. We know exactly where each element is, and in our computers eventually, that is sometime this fall, we can release pictures that will be appreciably better than what you're seeing here.
Saturn has been called the most beautiful planet in the solar system, and perhaps this picture is a good example of why. This is a close-up of two views, actually, of the rings, an image and then a mirror image as the imaging instrument stepped back across the rings. And this is the picture that gave us our first glimpse of the new ring system, the new outer ring at Saturn, and the Pioneer division between that ring and the outside of the A ring. Here's an enlargement of the previous view. The planet appears oblate. It is oblate. The diameter quite a bit larger at the equator than it is down through the poles. Another close-up view of the cloud tops at Saturn. This is the image that was made at very near the closest approach point to Saturn. There's a great deal of data and information contained in this image that may not be readily apparent on your screen, but there's data here that will be studied by scientists for years to come. Coming out the other side of the planet now, we have another view of Saturn in crosslight, with the sun lighting the planet from the side. The Pioneer Saturn spacecraft is on its way out of the solar system, but will be tracked for a number of years yet to come, returning valuable data on the interplanetary medium, the solar wind. This is Pioneer Saturn mission operations.
With that sort of preview, maybe we can call up the Titan image, or one of the Titan images from last night. It doesn't have a lot of obvious features on it, I think you'll agree, but if you've heard the model builders talking, they haven't predicted a lot of obvious features. The other thing to notice is that this is really raw data. It's been processed, but only in the sense that it's been squashed back together again to make it look round. It gets very elongated when it goes for a long time in one direction and a shorter time in another direction.
And the good news that the Titan is there. The bad news is that we barely saw it. We were counting on, first of all, twice as much data because at the high telemetry rate. Secondly, we were counting on no data dropouts. So we have a good deal less data, and we're counting on lots of data in order to average it and beat down the noise. And I'd say we've said the temperature of Titan is 75 degrees Kelvin, plus or minus 5, which is about the temperature you'd expect for an object in equilibrium with the sun at that place in the solar system. And as you can see, there's no prayer of measuring a day-night temperature difference with these data. We are not looking at the surface. We are looking at the cloud tops or some point high in the atmosphere, and we cannot say what the temperature of the surface is. Do I gather that based on
on the data that you did get back with Titan, there is not insufficient temperature data with respect to the surface to ascertain whether indeed there is an atmosphere that could be hospitable to some life form.
I think there's plenty of other data, Earth-based data, that tend to rule out the possibility of high surface temperatures and therefore rule out life. But I'll leave the door open a crack. I will certainly agree with you, my data do not have much to say about the surface temperature. So, perhaps summary of Saturn, or rings first. I guess I've summarized the significance of the Titan data for you already. I think we can say that our eclipse data, just as we go behind the planet, just at the end on the right there, are consistent with other analyses that imply that the rings are centimeter size.
And the preliminary indications are that the masses are not high, that they are more consistent with the hypothesis of the rings being made of ices rather than something heavy containing a lot of iron.
On the planet itself, I think we've at least confirmed that these yellow bands are correlated with cloud heights. The various colored bands on Saturn are correlated with cloud heights, or by which I mean different colored bands are at different heights.
And then we come to this exquisite fine feature, the F ring, a very narrow F ring, which lies near or on the inside of the E ring, which we have not been able to observe, but I have little doubt that the E ring exists. And then this morning we heard then of the discovery of the G ring between approximately 10 and 15 radii.
Now I know the ladies and gentlemen of the press are probably a little bit perplexed by some of the complicated figures that we show you, so I thought I'd start with a simple one. This is it. Now this is my summary of the hard information we had, hard scientific information we had about Saturn's magnetic field prior to the Pioneer 11 mission. So we know that we can now turn this blank page and begin to concentrate on the fact that Saturn does indeed have a magnetic field, and we know what its properties are. And to paraphrase William Gilbert, who started this business originally back in the 1600s, might say Saturn is indeed a giant magnet. What we've shown here is the Pioneer rock, which we presume lies in or near the ring plane. This is the Pioneer spacecraft, which at this time was about 10 minutes after having crossed the ring plane and was moving inward towards periapsis. It seems clear that referring to this as a Pioneer rock was perhaps somewhat misleading. As you've heard, the energetic particles have given us some idea about the size of this thing, which we nearly missed. And several hundred kilometers is probably more comparable in cross-section to the greater San Francisco-Oakland area. So calling it a rock is perhaps not really the appropriate thing. As far as we know, what wasn't there, we went under it about 10 minutes after crossing the ring plane, and I would say, along with the others, that we were damn lucky.
What this shows, we'll just keep it at this for the moment, is how, using trajectory information, we can learn things about the interior of the planet. First, we show here just a core, an inner core to Saturn, which will produce a nearly spherical gravitational field. It will be slightly flattened, and we show, again, very schematically, a trajectory flying through that gravitational field. Now we can add in a region of metallic hydrogen, and that can be shown by here. We add metallic hydrogen on top of the core. This will change the gravitational field, flatten it even more, and we'll get a slightly different trajectory as a result of that metallic hydrogen region. And then finally we show the outer envelope of Saturn, the liquid hydrogen region, and we show in a very exaggerated way the shape of the surface, or the geoid.
We have a figure of the interior. This is built up by an inner core. I guess I have no control over how fast this accumulates, so we can let it go all the way out to the surface. But anyway, that inner core you see is made up of molten rock and iron. This model that we show here is essentially correct. It consists of about 3 Earth masses, but is of about the same size as the Earth. So we have a density of about 3 times what we have in the Earth, and a body of about the same size made up of rock and iron, but higher density by about a factor of 3 because it's inside of Saturn. Then we have an outer core where substances of water, methane, and ammonia have settled out of the upper regions of Saturn and formed a outer core consisting of about 9 Earth masses. And the boundary of that outer core is about 23% of the total planetary radius. Then on top of that is the metallic hydrogen region, which is consistent with the diagram that Ed Smith showed. And the boundary of that makes up about 58% of the radius. On top of that, a liquid hydrogen region. And then on the very top, a gaseous atmosphere, which we estimate to be about 300 kilometers deep.
Yeah, I just want to make a few closing remarks, and that is that, first of all, in the last 2 weeks, I think our knowledge on Saturn has increased by at least 1,000-fold, conservatively. And so I think, 2 weeks ago we didn't know very much about Saturn. I think we know a lot now. We got a lot of questions, and hopefully a lot of these will be answered as we analyze the data further. But I think we've learned an awful lot in the last 2 weeks compared to what we've known in the last 370 years or so.
Truly great strides were made by the Pioneer missions, but the Voyager spacecraft, which followed the Pioneers to Saturn, gave us even clearer pictures and much more information. During our next program, we will see planetary data received by scientists at NASA's Jet Propulsion Laboratory in California. Until then, this is Larry Ross saying goodbye from NASA's Lewis Research Center in Cleveland, Ohio.